In this video, we'll talk about solving inequalities involving addition and subtraction. There's a little bit more to it here than equations, and we'll talk more about the meaning behind inequalities when we're talking about having a variable involved. So let's talk really quick about, let's take x is less than 3 for an example. And what does that mean? Well, the idea is I want to think about what values can I plug in for x where this expression or this inequality remains true. If I think about it, I cannot plug 4 in here. 4 is not less than 3, so x can't be 4. However, I can pick 2 or 2.5 or 0.7. All of those are less than 3. So these are worth noting, and there's a way that we plot this. And usually when we're talking about solutions to inequalities, we're talking about a whole range of values, not just one value here, one value there. We're talking about there's a whole gambit. So the idea is if I wanted to plot this, I would go to 3, because that's ultimately what we're saying here is that x is less than 3. I'm going to put an open dot at 3, meaning x cannot be 3. If you think about that, if I plug 3 in, it's not going to be possible because 3 is not less than 3. It's a false statement, therefore it doesn't work. And then I'm going to go back down to my plot here. Anything to the left or less than 3 is fine. So this would be how I would plot this inequality. And in a lot of ways, we're looking for a visual to kind of represent what values of x work in an inequality. And this is part of solving that we'll have to kind of make these ranges, this solution set, if you will. Because we're not really talking about one value that works, we're talking about several. We're talking about a whole set of values that could make this potential inequality true. So let's go ahead and dive right into an example. Let's say that I have x plus 8 is greater than or equal to 10. And you might be able to think pretty intuitively, okay, well, x has to be 2 or more to make this true. And this one makes sense. Now, we're going to go through this in a way where we're kind of developing some skills so that as these inequalities get more complex, we can solve them for the ones that aren't so much intuitive. So if we think about this, where x plus 8 is greater than or equal to 10, it would also make sense that if I was to subtract 8 from both sides, I would still maintain this inequality. If this expression is already bigger than this one, if the x plus 8 is already bigger than or equal to 10, as long as I take 8 from both sides, that should still remain true. That relationship should still remain true. The side on the left should be greater than or equal to the side on the right. So when we're talking about addition subtraction, we can usually, or we can, there's no usually here, we can always treat it as we would an equation. Because if we think about an equation, if we have x plus 8 is equal to 10, well, we can subtract 8 from both sides without even blinking. X is 2. Turns out we can do that with addition subtraction with inequalities as well because of this property that exists. If I'm taking 8 away, I'm still, the left side is still bigger than or equal to the right side. So this would tell me x is greater than or equal to 2, which lines up with what we're kind of originally thinking here. Now, if I'm to plot this on a number line, I would go to 2, and in this case, because of the equal to, I'm going to make a solid dot, because x could be 2. This one's different than our last example where x was less than 3. And then what I'm going to do is it's going to be greater than 2. So it could be 2 or it could be greater, meaning I'm going to go to the right. I'm looking for values greater than 2. And if you're not sure which way to go, you can always try a value here. If I try 3, does it result in a true statement? In this case, it would be 11, and yes, it would work. 11 would be greater than or equal to 10. So therefore, it would work. And this would be my solution set. Any number that's 2 or bigger is basically what I'm saying here. And I'm just giving a visual for how it works. Now just real quick, I want to do one more example involving subtraction to show you that it would be the same thing. So let's say that we have 7 is less than x minus 4. Well, the idea here is, well, we know we can add and subtract from an inequality and still maintain this relationship. We can still say that the left side is less than the right side. It just has to be that way. Otherwise, how would it work? If I take the same thing from both sides, I should still be able to say that one is bigger than the other. So what we're going to be able to then say is that x is greater than 3, or 3 is less than x, however you want to read it. The important part to note here is that when I go to my plot, I go to 3, x is open at 3, meaning it can't be 3, but it can be anything greater than 3. And that's how we can solve inequalities with addition and subtraction. We will talk in another video when we're talking about multiplication, division, and then multi-step. So these first couple probably can be very, very intuitive. You probably don't need to think about them too much, but we're building this understanding so that when they aren't as intuitive, we can still solve them.